Imagine a world where the Arctic, once a frozen landscape, is now transforming at an unprecedented rate. The retreat of sea ice in the Arctic has long been a striking symbol of climate change, with observations revealing that the extent of sea ice at the end of summer has halved since satellite records began in the late 1970s. However, a surprising trend has emerged. The pace of Arctic sea ice loss has slowed markedly since the late 2000s, with no statistically significant decline for about 20 years. But here's where it gets interesting. This slowdown is only temporary. In new research, published in Geophysical Research Letters, my colleagues and I explored the reasons behind the recent slowdown of Arctic sea ice and turned to climate models to understand what might happen next. Our findings show that rather than being an unexpected or rare event, climate model simulations suggest we should expect periods like this to occur relatively frequently. This current slowdown is likely caused by natural fluctuations of the climate system, just as they played a part in an acceleration of sea ice loss in the decades prior. Were it not for human-caused warming, it is likely that sea ice would have increased over this period. According to our simulations, the slowdown could even last for another 5 or 10 years, even as the world continues to warm. The changes in the Arctic are one of the most clear and well-known indicators of a warming climate, with the region warming up to 4 times the rate of the global average. The Arctic has lost more than 10,000 cubic kilometers of sea ice since the 1980s, which is roughly equivalent to 4 billion Olympic swimming pools. Arctic sea ice reached its smallest extent on record in September 2012, dwindling to 3.41 million square kilometers. This triggered discussions of when the Arctic might see its first ice-free summer, where sea ice extent drops below 1 million square kilometers. Research has shown that human-caused warming is responsible for up to 2/3 of this decline, with the remainder down to natural fluctuations in the climate system, also known as internal climate variability. Despite the record low of 2012, satellite data reveals a widespread slowdown in Arctic sea ice loss over the past 2 decades. Climate model simulations of Arctic sea ice thickness and volume further reinforce these observations, indicating little or no significant decline over the past 15 years. But what's behind this slowdown? Is it surprising that Arctic sea ice loss could slow down, given that global warming is caused by the continued rise in greenhouse gas emissions? Not necessarily. The recent generations of climate models used for the Coupled Model Intercomparison Project, CMIP, illustrate why this might be happening. Models from CMIP 5 and CMIP 6, which simulate the historical period and explore different future warming scenarios, indicate that slowdowns in Arctic sea ice loss lasting multiple decades are relatively common, happening in roughly 20% of model runs. This is due to natural variability in the climate system, which can temporarily counteract the decline of sea ice, even under high-emission scenarios. One way that climate scientists investigate natural variability is by running multiple simulations of a model, each with identical levels of human-caused emissions of carbon dioxide, aerosols, and methane. These are known as ensembles. Due to the chaotic nature of the climate system, which results in different phases of natural variability, the different model runs produce different outcomes, even if the long-term climate change signal from human activity remains constant. For example, a shift from the positive warm phase to the negative cool phase of a natural cycle in the interdecadal Pacific Oscillation is associated with bringing much cooler waters close to the North American coastline and into the Arctic, which can potentially lead to sea ice growth. So what might happen to Arctic sea ice cover next? Climate model simulations suggest that the current slowdown might continue for another 5 or 10 years. However, there is an important caveat. Slowdowns like this often set the stage for faster declines later. Climate models suggest that when the slowdown inevitably ends, the rate of sea ice loss could rapidly accelerate. Thousands of simulations analyzed in our research reveal that September sea ice loss ramps up at a rate of more than 500,000 square kilometers per decade after prolonged periods of minimal sea ice loss. This would equate to more than 10% of current sea ice cover in September. An analogy of Arctic sea ice extent behaving like a ball bouncing downhill is particularly apt here. Just like the ball, which eventually reaches the bottom due to gravity, despite an erratic journey, Arctic sea ice loss may temporarily seem to defy expectations at present. Ultimately, however, sea ice loss will resume, reflecting the underlying human-induced warming trend. While it may seem contradictory that Arctic sea ice loss can slow even as global temperatures climb, climate models clearly show that such periods are expected parts of climate variability. As a result, the recent slowdown in Arctic sea ice does not signal an end to climate change or lessen the urgency of cutting greenhouse gas emissions if global goals are to be met. While the current slowdown might persist for some years to come, when sea ice loss resumes, it could do so with renewed intensity. And this is the part that most people miss. The temporary slowdown in Arctic sea ice loss is not a sign that climate change is slowing down, but rather a natural fluctuation in the climate system. But here's the question. What do you think is the most critical step we can take to address climate change and reduce the risk of rapid sea ice loss in the future? Share your thoughts in the comments below.